here we go. I will ask you to follow these steps here. Basically, draw a labeled diagram. Show detailed work and round final answers to 2 decimals. That's including angles, right? So I'll say sides, angles. So sometimes you will draw a diagram and then you'll start solving, be like, wait a minute, this doesn't make sense. Feel like you have to feel comfortable with having to either make changes to your diagram or starting from scratch because it just doesn't make sense. Okay, so sometimes having some scrap paper maybe to see, like, let's try it this way and see how it goes, right? So some definitions here. There's the angle of elevation, and depression. This is the key here. Both measured from a horizontal line. If you remember IPR, you definitely talked about that. Okay, and so basically this is what I'm going to give you here to make it as clear as possible. So we'll just have our good old stick man there, eye level. And so imagine there's the horizontal line, right? Basically going straight out, and you'll have 2 angles from that one. So that's going up would be your angle of elevation. Going down would be your angle of depression. So up here we'll just draw a bird, and down here we'll have an insect of some sort. Okay. The angle formed between the horizontal and the line of sight looking up, that angle is elevation. I should be writing angle of elevation, but you get the point, right? And the one that's below here is called angle of depression. Yeah. Why is this important? This is why. Okay. Common mistake. I'll put it right next to it because it happens all the time. So a student, right? You're at a cliff like this, and there's water there, and the question says, "Hey, you're at the top of the cliff, and the angle of depression is 36 degrees, right?" So and then you look at a boat out here. So this is actually correct. They'll make a line like this, and they'll say that, you know, this is the angle of depression. This is not the angle of depression. Because is there a horizontal in the mix here? There's no horizontal line, is there? So you have to imagine that it is up here. So this is the angle of depression. Or maybe you should circle this x, right? So you're not thinking that's angle, that's x is the angle we're trying to find. No, that's not it, okay? Just to make clear, you understand that that's not it. So if I ever give you a rectangle with a line, right? It's like, show me where the angle of depression is. Look for the horizontal and the incline like this. That's where it's located, okay? And this would be your elevation here, technically. Down here would be the elevation, but I'm not going to make that. This is the most common mistake, mixing these up, because you'll get it wrong. Okay, so we've got that out of the way. Supplementary angles. What do they add up to? 180. It is right to complement someone. So complementary is 90, and the supplementary, they add up to 180. And so in particular, if so I can think of an instance like this where there's the ground, there's the pole, right? And someone says, hey, they give you a diagram like this, and they tell you that this is 120. That angle is outside the triangle. But do you remember the straight line, straight angle property, right? It always, whatever is along that straight line, if you take them all, they add up to 180. In this case, there are only two, right? So this angle right here will be 60 degrees. Okay. So keep that in mind. That's probably the one that a lot of students miss that, or I don't know, like you got to make sure you take that into account. It's always there. Just bring it in. Yeah, go ahead. Just bring it in, okay? All right, next. We have that shortcut for finding the height of an oblique. Oh, it actually works every time. I'm just going to say of a triangle. This is a shortcut. If I have time, I'll actually show you why that works. But if you have a triangle like this, the height is always located right it goes from the base to the highest point. So the height is technically inside this triangle, and it always makes a 90 with the ground. So let's say you have this side is x and this side is y, and we will call this angle A here, and we will call this angle B. I'm using angles that are not x and y for a reason, because it makes the formula too messy. In general, right, to find the height of this thing, let's focus on this side right here. You take the side x here, right, and you multiply it by sine of A. You take this side that is touching that angle, right? So if you take x times sine of A, you get the height. Or you can say h is going to be y times what? Let's see if you see the pattern. If it's on this side, y times sine of B. Because the height, you would have to agree that the height would have to be the same, right? This height is fixed regardless of which side you're coming from. So they are the same. Okay. So that is an important one, because if I ever ask you, hey, what's the height of this triangle, or what's the area of this triangle, you need to know that. So the same works, also works, right? If you have a triangle that looks like this, oh, you can't see that, can you? And let's call this A here, and we'll call this X. Where would the height be out for this triangle? Where would you draw that? Would it be inside or outside the triangle? It's actually outside. So what you need to do, what you need to imagine, is you need to kind of just imagine that this base is extended, and now you're measuring to the very highest point of this triangle, and it always makes a 90. The height is here in this case. But it still works the same way. Height is still x, like whatever the side length is, times sine of A. I'm not going to do the y times sine of B, because it would also work. I just want you to know that that still is the same. Let's check here. Okay. This one's here. So let's actually go and try one. Example, a radio antenna is supported by two wires on opposite sides. The wires are anchored 60 meters apart. One wire has an angle of elevation. One wire has an angle of elevation of 62 degrees, comma, while the other is 75 degrees. A. Determine the length of each wire. B. Determine or calculate the height of the pole. Yeah, just so you know, if you ever hear guy wires, you know what a guy wire is? It's a supporting wire. It's a name that has been given to it. So if you see a hydro pole with like a wire on the side, like in an angle with a yellow jacket on it, right? So you don't hit it, that's a guy wire. It's just to support something from tilting, right? So don't, if you ever see that, don't let that throw you off. It's basically just a supporting wire. Okay, so here we go. Determine the length of each wire. First of all, diagram. So you should imagine a radio antenna. So there's a ground, you should imagine there's the ground and the antenna somewhere between, right? And I don't know, let's make it a dish or something, right? Radio antenna. And you have a wire going this way, and you have another wire going that way. Okay? We're going to assign letters in a bit. What else do we know? 60 meters apart, so they're anchored, right? Anchored means they're driven into the ground, and that is 60 meters from end to end. Okay? Got that taken care of. They're giving us two angles of elevation. So angle of elevation is between the horizontal and the line going up. So I'm going to go 62 here and put the other one over here. Not drawn to scale at all, but which one would you say, let's apply common sense. Which one of these two would you say is closer to the pole? 75? Why would you say that? You are correct, but right, you're looking higher up, right? The closer you go to something, the higher up you're gonna have to look, right? So technically this should have been redrawn and this should have been a little bit closer, but we're not gonna make a big deal. So we're gonna call this wire 1, right? And wire 2, X and Y right there. If you want to call this ABC, ABC, right? That's fine. I told you that lowercase is what we use. Yes, if it's all you're given is letters, triangle already, then maybe that's the way to go. But we're just gonna go ahead with this. Okay. Now, does the pole make a 90 with the ground? Yeah, technically yes. It's not said, it's not explicitly mentioned, but yes. So any pole or any structure, any building, we're assuming we're making a 90 with the ground. Okay. All right. Let's start solving now. How would you do this? Do you have a pair? No. No. A, S, A. Ignore this for a bit. We can find B, right? Okay. Angle B. I will say this, ASA, hidden pair. Okay. So angle B is 180 minus 62 minus 75. 43. Okay, so we've got that. Now I have a pair. I just want to make sure you know when you look back a month from now or a couple weeks from now that you can see what happened here. So this angle right here is 43 degrees for the whole thing. Okay, so sine, we're now solving for A here, sine of 43 over 60 meters is equal to, depends on which one you want to do first. If it's sine of 62 that we're using, we're solving for y. That is important to me. If on a test you mix those up, you will be in trouble, okay? Because you need to understand the concept, right? So it's 60 times sine of 62 over sine of 43. Y is equal to 77.68 meters. And then we're going to go sine of 43 again over 60 meters. And that's sine of 75. I'm going to use the other one over x, because 75 is across x. And I'm using the same pair that I started with. I don't switch those normally. Like, I stick with that one because I know it's true. So x is going to be 60 times sine of 75 over sine of 43. Should it be shorter or longer than the one we just found? Should be longer. It should be the longest, right? Sine of 43, that's 84.98 meters. So there are your two wires. And I know that you mean, right, that these are the lengths of the wires because you gave me an awesome diagram, right? All labeled, it's all there. B, how would you find the height of the pole? I just gave you the shortcut. So let's focus, either side will work. So height is going to be what side x? It's 84.98 times sine of 62, which is going to be, my other calculator is out of reach here. So it's 75.03 meters. Or we got to put this to the test. You have to do it. Or let's focus on the other side. That side length is 77.68. And what's the angle right next to it? It's 75. Hopefully this works. 75.03. Okay, that's it for today. Only one example. Where's my worksheet booklet? It's right here. So I have some questions that just deal with these types. So page 12 in workbook. And don't look at the key. It's right next to it. I didn't want it to be like that, but it's all worked out right next to it. So fold it so you're not looking at the key, right? Don't be cheating, right? Like it's easy when you look at the key.